the factor theorem. So based on the remainder theorem, right? When the remainder is 0, then we have a factor, okay? So the factor theorem says let f of x be a polynomial if f of c equals 0, then x minus c is a factor of f of x. If you recall from the remainder theorem, f of c is the same thing as the remainder. So if the remainder is 0, then f of c is 0. But if f of c is 0, then guess what? That thing x minus c is a factor of f of x, okay? Because the remainder is 0. Like if you talk about 2 as a factor of 6, that's because 6 divided by 2 is 3 with no remainder. 2 is not a factor of 7. If you divide 7 by 2, you get 3 with a remainder of 1. So 2 is not a factor there, right? So then the other side of that is if x minus c is a factor of f of x, then f of c equals 0. So why is this important? What does it help us with? Well, let's say that we have this function f of x, or this polynomial, 2x cubed minus 3x squared minus 11x plus 6, and we're told that negative 2 is a 0. Well, if we're told that, then that means that we know what? If negative 2 is, that's like my c. If that's a 0, then what is x minus c? That's x minus a negative 2, right? Which is x plus 2. But remember, when it's in the x minus c form, this means to do what? Change the sign. Anytime you have a negative in a formula, it means change the sign. It does not mean subtract. It means change the sign, okay? So we're going to change the sign. So I won't show this every time, this x minus a negative 2. I'm just going to remind you, hey, change the sign. So it's x plus 2 is what I'm dividing by. So if I were to factor this, I already know that x plus 2 is going to be a factor, and then I get something else to fill in there, okay? I get something else to fill in there, but it's got to be x plus 2 because negative 2 is a 0. So then x minus negative 2 or x plus 2 is a factor based on this right here, based on the factor theorem. All right. So how do I find out the rest of this? Let me fix this parenthesis here. How do I find out, like, what is this part right here? Well, we're going to use synthetic division. Okay. We're going to use synthetic division. And if I use synthetic division, then let's see. Let's come over here and put this on the porch. Let's put negative 2 on the porch, right? Because c goes on the porch. We don't have to change the sign here if we know what c is. It's if it's in the x plus or minus form, we change the sign. And then my coefficients are 2, negative 3, negative 11, and 6, right? I took these numbers right here. Oops, that negative goes to the 11. And then I took those things there for here, right? So the first thing I do on synthetic division is what? I drop down my first number into the basement. Then I say negative 2 times 2 and write it here, and that's going to be negative 4. And then I add. Add means don't change the sign right here, right? That's what it means, don't change the sign. So then really when I add negative 3 and negative 4, see a minus sign to subtract. No, you're adding. Well, actually, add here means don't change this sign. And then I have what? 2 negative signs, and when I combine 2 negative signs, I add them and keep it negative. 3 plus 4 is 7 and keep it negative, right? Then again, I start the process over. Negative 2 times negative 7, write it right here. Negative times negative is positive. 2 times 7 is 14. So negative 2 times negative 7 is 14. And then I add. I don't mean that I add them. I mean that I don't change the sign right here. And then a negative and a positive get subtracted. 14 minus 11 is 3. 14 is larger than 11, so we keep it positive. And then I start the process over again. Negative 2 times 3 is what? It better be negative 6 because we were told this is a 0. So really I could have already filled this in right here, right? So this is negative 6. What is 6 minus 6? 0. If you know something is a 0 to start with, if I know it's a 0 to start with, and I get any other remainder than 0, then I messed up, right? I made a boo-boo, put a Band-Aid on it, and start over again, okay? I have to get 0 there. If I don't, then I messed up. I'm going to now take this, and this is going to give me what goes right here, okay? Well, if I took it from the coefficients, then I divided x to the third by x. If you divide, you subtract powers, right? 3 minus 1 is what? 2. So now this represents x squared. This is x's, and this is my constants, okay? So this is 2x squared minus 7x plus 3. Once you get to x squared, then hopefully you can factor that trinomial and finish factoring this without doing this process again, okay? So here, what I'm going to do is leave my x plus 2 out front, and then I'm going to try to figure out, okay, what goes in here to factor this into two other binomials. It may not. Not everything that's a trinomial with x squared factors, all right? But if it does, we want to factor that for sure. So I'm going to come out here to the side because I notice this is 3 terms and there's a 2 out front with no GCF. That tells me that I'm going to use the method called bottoms up that I use, all right? So I'm going to take the 2 times the 3, and I'm going to put into my thought cloud out here, because I'm going to have a little thought cloud because it's not equal to what I'm about to write down. X squared minus 7x plus, if I move my 2, that becomes a 6. And now that is my list method. And list method is super easy to factor if you know the rules. It's the factor 6 that add to give me 7. I'll come back to the negative sign in a minute. 1 and 6, 2 and 3. All right, so this is going to be x and x. And the ones that add to give me 7 are 1 and 6. So I'll put in here a 1 and a 6. And it doesn't matter if you put the 1 first or the 6 first, right? Just go watch the list method video to see this, all right? So now, this sign, this says they're the same. I know that these are different, plus minus, but they're both whatever's first. So that tells me that both of these signs down here are negative. And then I've got to go back in and say, okay, I multiplied by 2. How do you undo multiplication? You divide. And both these numbers came from the 6, so divide them both by the thing I multiplied by. So if I multiply by 2, divide by 2 over here. All right. Does 1 over 2 simplify? No. So that's where the bottom comes up. 2 comes in front of that, so it becomes 2x minus 1. Over here, 6 over 2, yes, that becomes a 3, and there's nothing but a 1 left down here. We don't bring a 1 up. 1x and x are the same thing. So that parenthesis becomes x minus 3. And if you were to FOIL this out, you would end up with this blue polynomial above it, okay? So x plus 2, 2x minus 1, and x minus 3 are my factors. That's my factored form of this polynomial here that I started with, right? So that's all this question asked us to do was factor that. And the first factor we were given because of this. When we're told that negative 2 is a 0, that gives us one of our factors. So let's take this one step further, right? And if you remember, how did we get the zeros? You get zeros from factoring and setting each factor equal to 0. So if I can factor this, then guess what I can also do to this? I can also solve it. So I'm going to solve one, but I'm going to solve a different one, okay? So I gave you a hint here. Factor it first, then find the zeros, because that's how we solve these things. If we can, we factor them first and then solve them. The difference here is this 4-term thing that we have. See, the only way when we learned how to solve by factoring, the only way to do that was to group with 4 terms. Well, now we are learning how to handle those polynomials that grouping does not work on. I believe that no matter how you rearrange this, you're not going to get grouping to work. No matter what you do to this, grouping is not going to work. So we need to find some other way to try to factor this. Okay? So we're told that negative 1/3 is a 0. That's my C. So what do I know then? X minus C is the same thing as what? X plus 1/3, right? X plus 1/3. So if I want to come down here, I know that I have x plus 1/3, and then I'm going to have a bigger parenthesis. That's going to be my next power down, which since it starts at 3, this is going to be an x squared. I know that already, right? And that's going to equal 0. I just need to figure out, hey, what is this stuff in here, right? What is that in there? So how do I find that again? I'm going to use synthetic division, okay? I'm going to use synthetic division. So I'm going to come out here to the side, and I'm going to have a 3, a 7, a negative 22, and a negative 8, right? And then I have my house is upside down with a porch or a balcony, right? And the thing that goes on the porch is my C, which I'm given in this case. This number here is C, so it goes directly onto the porch, okay? And now I'm ready to use synthetic division for this one. So I'm going to drop the 3 down into the basement. Then I take the negative 1/3 times 3 and I write it right here. What is negative 1/3 times 3? Well, look, 1/3 times 3, right, is 1. So it's negative 1, right? 1/3 times 3 is a negative. This is over 1. Those divide out and become 1. So you're just left with good old negative 1 there, right? So all that's negative 1. So then I come back and I say, okay, now add these together because that means don't change this sign. But really, since the signs are different, I'm not adding, I'm subtracting because I didn't change the sign here, and then I'm combining like terms. So 7 minus 1 is 6. Then I start the process over. Negative 1/3 times 6 and write it here, okay? So again, negative 1/3 times 6, 6 is really over 1. That divides to a 2. So, and this is a 1, so then you have 2 over 1. So this is a good old what? Negative 2 is what that is. It's a good old negative 2. So negative 1/3 times 6 is good old negative 2. When you multiply these together, you get this. And then you say, okay, add. That just means don't change this sign. Now, if the signs are the same, what do? That's right, I add and keep it negative. So 22 and 2 is 24, and I keep it negative. And then I'm ready to start my process again. This times this, put it here. Okay? So negative 1/3 times negative 24, right? 2 negatives make a positive. Get rid of that. This is over 1. What is 24 over 3? It's 8. So this whole thing becomes 8. But we knew it should have. Right? Why do we know that? Because negative 8 plus 8 is 0, and my remainder better be 0 if I'm told that negative 1/3 is a 0, right? If I put negative 1/3 right here, I better get 0 right there. If I don't, then I messed up, or I was lied to 1. All right? So now, again, I'm going to take this and put it here by putting the x's back into it, right? So again, if this represented x to the third, this is now x squared. It goes down 1 power because you divided by 1x here, okay? So 3x squared plus 6x minus 24. The first thing I see when I look at this is I have a GCF. That's always the first thing you should look for when you factor something is there a GCF? And in this case, there is a 3. So I'm going to take that 3 out front, leave the x plus 1/3. I just brought the 3 all the way in the front. And then here I have x squared plus 2x minus what? 8. And then keep this 3 and this x plus 1/3 out front. And then can I factor this further? The reason I try to factor further is that x squared. It won't always work, but if the power is bigger than 1, then I try to factor. There's no pluses or minuses here that are not in parentheses, but my power is bigger than 1. So I'm looking for the factors of 8 that subtract to give me 2. All right, again, they are 1 and 8 or 2 and 4. 1 minus 8 is 7. That won't work, but 4 minus 2 is 2, right? So 4 and 2. This says the bigger number gets this sign. I mean the bigger of these two. 4 is bigger than 2, so it gets a what? A plus, and 2 gets a minus. The only way to get a negative 8 here is for those to be different, okay? And we determine bigger number gets this sign, okay, whatever it is. If it's minus, they get a minus, plus, plus, okay? Again, that's in the list method video. And then this whole thing is still equal to 0. Now this thing is completely factored. I'm ready to set each factor equal to 0. Again, I can take this 3 equal to 0 out front, but you can look at it and go, Mr. Guest, that does not have any x's in it, so it's not, or any variable, so it's not going to give me a 0. So 3 equals 0 is no good. If that was 3x, it would give me something here. It does not. And then x plus, I really know what this one already is, right? If I solve it, I really already know that this is negative 1/3. I'm told that. So I'm solving it, but I mean, I already knew this one, right? This one was the one I was given. So if I had me a good old answer box over here, if I had me a good old answer box here on a test or something and I had x equals, then I could have already written this in here from when I started because look, negative 1/3 is a 0. So that means if I set it equal to 0, negative 1/3 is going to be one of my answers. So that one's already there. And then come over here and subtract 4. X equals negative 4, comma. Don't forget a comma if you have more than one of them. And then here. So earlier we listed the zeros out here. We're just putting them in a box. Either way, it doesn't matter. I didn't have the box to begin with. However you want to answer them, circle them, whatever. So negative 1/3, negative 4, and 2 are my zeros here. I was given this first 0, so that gave me the place to start. That's nice when you're given one, but you're not always given one, okay? So, but here, given these, using the remainder theorem, find these, okay? If you watch the video solving polynomials, then it takes the whole kit and caboodle where you just start with this and you have no idea any of these. And you just start and solve. All right?